There's a rock out there right now tagging along with Earth as we circle the sun. It's about the size of a school bus. Nobody put it there. Nobody's tracking it with a joystick. It just showed up on a telescope in 2016, and scientists have been arguing about it ever since. Here's why it matters. For the last few years, the leading theory was that this thing used to be part of the moon, like literally blasted off the lunar surface by an ancient impact and drifting near Earth ever since. A piece of our own moon hiding in plain sight. This week, a Chinese spacecraft that's been chasing this rock for over a year finally got close enough to snap a photo of it. Visual. Push in from Earth orbit past the moon to a small tumbling rock. And that photo, plus some other data that's come in recently, might actually be turning that whole piece of the moon theory on its head. So let's get into it. What is this thing? Why did China spend a decade planning a mission to go grab a piece of it? And what did we just learn? Quick heads up. Mini Moon is a nickname the press uses. It's not really accurate, and once you understand why, the actual story gets more interesting anyway. The object is called Kamo'olaiwa. You say it Kamo'olaiva. It's a Hawaiian name, pulled from a creation chant, and it roughly translates to something like an offspring that travels on its own, which honestly is a pretty good description of what it's doing, because Kamo'olaiwa doesn't actually orbit Earth. It orbits the sun, same as every other asteroid out there. The catch is that its orbit is so closely matched to Earth's that the two of them basically stay next to each other the whole way around. Astronomers call this a quasi-satellite. Think of two runners on a track who happen to be running the exact same pace. They're not tied together. They're just always in step. What's unusual is how long this has been going on. Most objects that fall into this kind of loose partnership with Earth wander off after a few decades. Kamo'olaiwa isn't going anywhere. Models suggest it'll keep pace with us for millions of years. Astronomers have found about 8 of these Earth-trailing objects so far, but this one's the closest, the smallest, and up until now, the hardest to actually study. At its nearest, it gets to within about 9 million miles of us. At its farthest, it swings out past 25 million. For comparison, our real moon sits at roughly 250,000 miles, so don't picture this thing hanging in our sky. It's a distant traveling companion, not a second moon in any visible sense. It was picked up in 2016 by the Pan-STARRS telescope on Haleakala in Hawaii, which, again, is where the name comes from. And based on the size Tianwen-2 is now confirming, we're talking about something between 130 and 330 feet across. Roughly a football field at most, which makes it the smallest asteroid any spacecraft has ever pulled up next to. So, on paper, small rock, weird orbit, discovered less than 10 years ago. Not exactly a mission-worthy target at first glance. So why did China build an entire spacecraft to go chase it down? Because of what it might actually be made of. Back in 2021, a team out of the University of Arizona pointed one of the most powerful telescopes on the planet, the Large Binocular Telescope, at Kamo'olaiwa during its brief viewing window, which only opens up for a few weeks each April. What they saw didn't add up. The light bouncing off the surface, what scientists call its spectral signature, didn't match any known asteroid, but it did match something else: lunar rock. Specifically samples the Apollo 14 astronauts brought back from the moon decades ago. Ben Sharkey, who led that research, later said he went through the spectrum of basically every known near-Earth asteroid trying to find a match and came up empty, except for the moon, which raises an obvious question. If this rock is made of lunar material, how did it end up out here, millions of miles from where it started? A few years later, in 2024, another research team tried to answer that with impact simulations. Their leading candidate was the Giordano Bruno crater, a massive scar on the far side of the moon. According to their modeling, it would have taken something at least 1 kilometer wide, slamming into the lunar surface to launch a piece of rock with enough force to escape the moon's gravity entirely and settle into this strange orbit alongside Earth. If that's actually what happened, Kamo-o-Alewa isn't just near the moon. It is the moon, or at least a piece of it, drifting through space, quietly, for what could be millions of years, until someone finally noticed it in 2016. And here's why that matters so much to scientists. Outside of the Earth-Moon system itself, we don't have a single confirmed sample of lunar material anywhere else in the solar system. If this theory holds up, Kamo-o-Alewa would be the only one. A natural time capsule that got blown off the moon and just kept going. That idea alone is what turned an obscure little quasi-satellite into one of the most sought-after targets in the solar system. And it's exactly why China set its sights on it. The mission is called Tianwen-2, roughly Questions to Heaven. It's run by the China National Space Administration, and it's the second flight in China's Tianwen planetary program, after Tianwen-1 put a rover on Mars back in 2021. Tianwen-2 lifted off on May 28, 2025, from the Xichang Satellite Launch Center on a Long March 3B rocket. And the launch itself was a first. That particular rocket had never been used to send anything past Earth orbit before. To pull it off, the rocket had to hit escape velocity right out of the gate, over 7 miles per second. Engineers said afterward that a targeting error of just 1 meter per second at launch could have thrown the spacecraft off course by up to 100 million kilometers by the time it reached its target. That's the kind of precision this mission needed just to get off the ground. From there, it was a long haul, about 400 days in transit, covering roughly 621 million miles, using solar electric propulsion to nudge itself along the way. On July 4th of this year, Tianwen-2 finally arrived in Kamo-o-Alewa's neighborhood. By early July, it had closed to within about 12 miles, or 20 kilometers, of the surface. That's when the picture came back. It confirmed what researchers had suspected for a while. This isn't a smooth little sphere. It's a small, elongated, tumbling rock, rotating on its axis roughly once every 28 minutes. Not a simple boulder, something irregular, spinning through space on its own clock. Chinese space officials said the spacecraft would spend the coming months studying the asteroid's shape, composition, and internal structure in more detail. All of that groundwork is building toward the part everyone actually cares about, physically reaching out and grabbing a piece of it. That part is where the mission gets genuinely clever. Nobody has ever tried to land equipment on something this small before, so the engineers behind Tianwen-2 built in 3 completely different ways to collect a sample. Basically a backup plan for the backup plan. The first is touch and go. The spacecraft briefly makes contact with the surface, grabs whatever it can, and pulls back immediately. NASA used this same basic approach with OSIRIS-REx, and Japan used it with Hayabusa 2. Both missions successfully brought asteroid material back to Earth. The second is a lot more ambitious: anchor and attach. The spacecraft would physically latch onto the asteroid using drill-equipped legs, holding itself in place long enough to pull material from the surface and just beneath it. The third is a hovering method, where a robotic arm reaches out while the spacecraft hangs above the surface, scooping up loose material without fully touching down. Here's the part that makes the timing of all this so strange. Right around when Tianwen-2 was closing in on its target, new evidence started pushing back against the very theory the mission was partly designed to test. Back in February, the James Webb Space Telescope took a fresh look at Kamo-o-Alewa. Combined with new follow-up observations from the Large Binocular Telescope, the results showed a spectrum that was noticeably less weathered than expected, less like beat-up lunar material, and more like an ordinary silicate asteroid, the kind that makes up a huge chunk of the general asteroid population. On top of that, Tianwen-2's own first image suggested the surface reflects a lot more sunlight than lunar material typically does. Moon rock tends to be dark. This didn't look especially dark. Some scientists, astronomer Mikhail Granvik among them, now lean toward Kamo-o-Alewa being a fairly normal silicate asteroid rather than a chunk of the moon. But it's not settled. Not even close. You can't fully rule out the lunar origin idea just from remote observations. The only way to actually answer this is to get real material into a lab here on Earth, where scientists can study its actual chemistry instead of just reading reflected sunlight from millions of miles away. Which means that little capsule Tianwen-2 plans to drop off in late 2027 isn't just a bonus. It might be the only way we ever find out for sure whether this thing came from our moon or from somewhere else entirely. So where does this go from here? Tianwen-2 is going to spend roughly the next year parked near Kamo'olawa, mapping the surface, refining what we know about its shape and spin, and picking the safest spot to actually attempt a sample grab. Current planning has it leaving the asteroid around April 2027. From there, it swings back toward Earth and releases its sample capsule during a close flyby, expected sometime around late November 2027. That capsule parachutes down near the Jiuquan launch site in northern China. The same general area China's used to bring lunar samples home before with its Chang'e missions. But the spacecraft itself doesn't come home. Once it drops off the capsule, Tianwen-2 uses Earth's gravity like a slingshot and heads straight back out. This time toward a comet called 311P/Pan-STARRS, way out in the asteroid belt between Mars and Jupiter. And 311P is a strange one. Technically, it's classified as an asteroid, but it acts like a comet. Hubble once caught it sprouting up to 6 separate dust tails at once, likely from spinning fast enough to fling material off its own surface. Scientists lump these into a category called active asteroids, and honestly, we still don't fully understand them. Tianwen-2 is expected to arrive around January 2035, and spend at least a year studying it up close with a full suite of 11 instruments. So this one spacecraft launched in 2025 is running a mission that doesn't actually wrap up until the mid-2030s, a single 10-year journey, touching 2 completely different kinds of objects along the way. It's easy to file this under cool space headline and move on, but zoom out for a second. If Kamo'olawa really is a piece of the moon, this gives scientists something they've never had: a direct physical sample from a major lunar impact, preserved out in space instead of buried and weathered on the moon's surface for millions of years. That could genuinely reshape what we know about the moon's violent history. And if it's not lunar material, if it's just an unusual asteroid, that's still a real discovery. It means researchers have to rethink how objects even end up locked into these strange Earth-trailing orbits in the first place, which opens up a bigger question. What else might be quietly riding alongside us that we simply haven't spotted yet? Either way, we learned something we didn't know. And in about a year and a half, thanks to a spacecraft that's already logged over 600 million miles, we're finally going to get an answer. So next time you look up at the moon, keep in mind, it might not be traveling alone. There's a rock the size of a school bus that's been quietly keeping pace with Earth for who knows how long. And for the first time, we're actually close enough to find out what it really is. If this kind of thing interests you, stick around. I cover real missions like this one, not sci-fi speculation. And drop a comment. Do you think Kamo'olawa turns out to be a piece of the moon or something else? Thanks for watching. See you in the next one.